Hello, this is Brother Cromar from the Math Department at BYU, Idaho, and this video will be covering, or I'll be covering, Lesson 7, which is dealing with finding probability or area within a sampling distribution. And so the outline for this video will go as follows. First, I'll be reviewing Lesson 5, which is finding area or probability within a normal distribution curve. And then the second thing we'll review is Lesson 6, which is review the mean, the standard deviation, shape of a sampling distribution when the population data is normally distributed. And then we'll cover new material, which is finding area or probability within a sampling distribution when the population data is normally distributed. And then these last two items will be similar to the second and third items, but instead of the population data being normally distributed, it'll be not normally distributed. And so we'll review in terms of how to get the mean, the standard deviation, shape of the sampling distribution, followed by how to get the probability of a sampling distribution when the population data is not normally distributed. Okay, so now let's review Lesson 5. So here's a problem where we've dealt with finding area under a normal curve. The length of a human pregnancy from conception to birth is normally distributed with the mean of 266 days and a standard deviation of 16 days. What is the probability of a pregnancy that lasts less than 260 days? Well, there are two steps. Step 1 is to convert the value of x, the x being 260 in this case, using a standard normal variable z. And so here's the z-score where we take our 260 minus the mean, which is 266, and divide it by our standard deviation, which is 16, to get a z-score of negative 0.375. And what this means is that the z-score represents is that the 260 is 0.375 standard deviations away from the mean, but since it's negative, that the 260 is on the left side. Okay, and so what we do after that, and I'll just do this here, I'll go to the applet, here's a representation of the applet, but I'll go to the applet, and if you type in negative 0.375 down here, and then press enter, you will get this area under the curve, and this area represents 35%, about 35% of the entire area, and then the result you'll see just up above, in this applet that we have here at BYU, Idaho. Okay, and so we conclude that about 35% of all pregnancies last less than 260 days. Okay, so that reviews us. If I now I could ask the question, what's the probability of it being greater than 260 days of pregnancy? So instead of shading to the left, we shade to the right of this z-score to get the probability. Okay, or you could just take 1 minus this probability, which is about 0.6462 to get the probability that it's greater than 260 days. Okay, so now let's go review the mean and standard deviation and shape of a sampling distribution when the population data is normally distributed. So the length of a human pregnancy, going back to the original problem, from conception to birth is normally distributed with a mean of 266 days and a standard deviation of 16 days. Suppose a random sample of 30 pregnancies was measured. What is the mean, the standard deviation, and shape of a sampling distribution for the mean pregnancies based on a sample of 30? Well, the mean of our sampling distribution, or mean of all possible means, is equal to the mean of the original population, which is 266 days. Okay. The standard deviation of our sampling distribution is the standard deviation of the original population, which is 16 days, divided by our sample, the square root of our sample size. Our sample size is 30, and we'll get a new standard deviation of our sampling distribution of 2.92. The shape is a normal distribution, and even though the sample size you might consider that to be large, but what trumps that is that the original distribution is normally distributed. Hence, that's why the shape of the sampling distribution would also be normal. You can have a sample size of 2, and your sampling distribution will still be normal. Okay. Now let's cover the new material, finding area or probability within a sampling distribution when the population data is normally distributed. So say the length of a human pregnancy from conception to birth is normally distributed with a mean of 266 days, standard deviation of 16 days, so the same problem. Now I'm going to ask a different question. What is the probability of a random sample of 30 pregnancies that have a mean pregnancy period less than 260 days? Notice that this question is worded differently than the previous question up here, which is what's the probability of a pregnancy that lasts less than 260 days? Now we're asking it here is what is the probability that a random sample of 30 pregnancies, it should say have a mean pregnancy period less than 260 days. So what we do is we do the same two steps, but notice here we look at our z-score. I used the same problem where I used 260 here, like the last problem. Now we're dealing with the mean being less than 260 days. Notice here that the thing that changes is what's in the denominator. The 16 divided by the square root of 30. This is the new standard deviation of our sampling distribution. This is what we did on the previous slide. This is the 2.92. That is the standard deviation. That's what we put in now in our denominator for the z-score. And when we solve for this z-score, we get a z-score of negative 2.05. And so in this case, what this means is that the sample mean, 260, is just over 2 standard deviations away from the mean, but now on the left side. Okay, so we get a z-score, and so the next thing what we do is we find the area under the curve. And so what we do now, I'll go to the applet, is that I type in negative 2.05, press enter, and now we have a new area under the curve. And so what is that, and how do we interpret that? What we say is that that the probability that a random sample of 30 pregnancies have a mean pregnancy period of less than 260 days is about 2%, or 0.0202. Okay, so now what I want to do is I want to go through here. Let's review. I'm going to put this up here. So the heart rate for a typical college student is normally distributed with a mean of 80 and a standard deviation of 16.5. Suppose a random sample of 10 students was measured. What is the mean, the standard deviation, and shape of a sampling distribution for mean heart rate for a typical student based on a sample of 10? So first of all, what is the mean? Let's review that. What is the mean of the means? Well, the mean of the means is equal to the mean of the original population, which is 80. The standard deviation, what is the standard deviation? Well, the standard deviation is taking the original standard deviation, which is 16, divided by the square root of our sample size, which is 10. We get this to be 5.22. And then what's the shape of our sampling distribution? Well, the shape is still normally distributed. Even though we have a sample size of 10, as I alluded to earlier in the video, even though it's a small sample size, since the original distribution is normally distributed, the shape of this will be a bell-shaped distribution. Okay? So now let's go take this information here and deal with another problem. The heart rate for a typical college student is normally distributed with a mean of 80 and a standard deviation of 16.5 beats per minute. So what is the probability that a random sample of 10 college students has a mean heart rate greater than 90 beats per minute? So stop the recording and try to figure out what the z-score might be. Or I should say stop what you're doing here on YouTube. Okay, so what you would do here is you would take 90 minus the mean, which is 80, divided by the standard deviation, which is 16.5, and then we divide it by the square root of 10, 10 being our sample size. Now we have a z-score, which is 1.917. So this means is that the sample mean of 90 is 1.97 standard deviations away from the mean, the population mean, which is 80. So then what would be our second step? So stop the video and see if you can do this on step number 2. Okay, so what you would do here is, I don't need to put this into the applet here, but I'll show you here that this is how you would get your information here. So we're looking for, now notice here, so you put in our z-score 1.917 on the right side, and then you shade to the right bit because the question is asking for what's the probability that a random sample of 10 college students has a mean heart rate greater than. So here you would shade to the right. And so what does that mean overall for this problem? This means that there's a just under 3% chance, or the probability that a random sample of 10 college students has a mean heart rate greater than 90 beats per minute is just under 3%, or 0.0276. Okay, so now what I'd like to do is, what I'm going to do is I'm going to stop the recording, and I'm going to have part 2 of the recording, and we'll wrap up this lesson 7.